roughly 238,000 miles away from Earth and over 2,100 miles wide, the Moon is the most obvious and recognizable object in the night sky. It's the only celestial body ever visited by humans, yet remains something of a mystery to many people, even though many of its features can be easily seen with binoculars or even a small telescope. Yet the Moon has a special place in our minds and has appeared in many tales of love and even horror for centuries. Not made of cheese and with no man in the moon present, it's a celestial body which holds possible answers to some very important questions like the formation of the Earth and even the solar system. It can provide a base for deep space operations and provide a location to better view the universe. No atmosphere and low gravity make it ideal for these tasks. Therefore, we'll take advantage of the Moon's phase this week in order to see and identify some of its features. Locate the white lettering. Some of these are lunar mare, or seas as they were first thought. Of course, there is no water on the Moon, but early observers didn't know that. In fact, these mare are the results of huge meteoroid impacts very early in the Moon's history, which caused molten lava to pour onto the surface, creating these vast flat surface areas. Beginning on the top right of the Moon is Mare Frigoris, or the Sea of Cold. It's about 55 miles wide and 750 miles long. To the left, there are the Alps Mountains and a large crack separating them called the Alpine Valley, a special kind of geologic fault called a graben. A little further left is Mare Imbrium, or the Sea of Showers, one of the largest mare on the Moon with a diameter of about 700 miles. It's partially surrounded by 3 mountain ranges, beginning with the Alps. Below them we find the Caucasus, and finally the Apennines. A special point of interest here is the landing site of Apollo 15 at Hadley Rill. Continuing down the Moon, we encounter Mare Vaporum, the Sea of Vapors. To its right is Mare Serenitatis, the Sea of Serenity, with the Apollo 17 landing site at Taurus Littrow. Below Mare Serenitatis is Mare Tranquillitatis, or the Sea of Tranquility. The Apollo 11 landing site was at the bottom of the mare outside of our current field of view. To the left, we find 3 named craters, and then on to Mare Nubium, the Sea of Clouds. Numerous impact craters are clearly seen in this view, all written in red. Beginning at the top, we find the crater Plato, about 67 miles wide. Notice how flat the crater floor is? It was filled with lava after impact, leaving most of the crater wall submerged in, then, molten rock. Below Plato we find Linicus, another flooded crater. Just to its left is the crater Eratosthenes, with a width of about 35 miles and a depth of over 2 miles. In this example of a lunar crater, we see a steep slumping wall leading to a typical crater floor. The central peak, not visible in this image, is a common feature of impact craters and is the result of a splashback effect of the molten rock created by the initial impact. So, yes, surface rock is instantly liquefied by the impact of a large meteorite, like the one that created Eratosthenes. A little further on south, we finally find 3 craters we mentioned previously. The first is Ptolemaeus, a flood crater about 90 miles wide and 1.5 miles deep. Second, we find Alphonsus, over 70 miles wide and about 0.5 mile deep. This crater was the subject of the very first investigation of the Moon by spacecraft in 1964. That was Ranger 7. Finally, we come to the crater Arzekiel. It has a diameter of about 57 miles wide and a depth of over 2 miles. Notice that Arzekiel and Alphonsus both have central peaks, although both craters have had some lava flooding across the floor from the creation of the impact. Now, let's move to the other half of the moon. Here, we find the Southern Highlands, a vast area of craters along with other interesting features. We'll begin at the top with a feature called Strait Wall. This is another geologic fault stretching 68 miles long and with a height of almost 1,000 feet, and a width in places between 1 and 2 miles. The view from the top of that fault must be absolutely incredible. Below Strait Wall, we find a crater chain, which looks more like a crack in the moon below the crater Walter. Yet if you look close, the small craterlets can be seen. Given the size and proximity of each of those, they were probably a small asteroid group that were traveling through space together and impacted at much the same time. The large crater complex to the far left is the one we'll discuss next, and is called Clavius. It's the third largest on this side of the moon, about 140 miles wide and about 4 billion years old. With many much younger looking impact craters inside, it clearly looks its age. Check it out on the internet. It has a lot of interesting facts connected to it that you'll find there. Observing the moon can be interesting, and occasionally an added bonus may come along to pique your interest. Watch the video closely. Something is about to appear. Yet, this was another of Earth's satellites, only this one was one that we made. If you watch long enough, you can see planes or birds fly by, or even satellites. And if you're really lucky, you might even see the International Space Station sometime. These encounters make for exciting observing. In previous installment, we discussed some of the features found on the moon that are easily seen by binoculars or even through a small telescope. Yet that list was not by any means complete. There is still one more lunar feature we need to discuss: craters and how they're formed. Actually, there are two types of craters: volcanic and those created by impact from meteors. Volcanic craters are produced by geologic forces within a planet or moon. Although there is evidence for volcanic activity on the moon in the past, craters of this type are, by far, not the most common. Impact craters, formed from meteors crashing into the moon, can be seen across the lunar surface. They range in size from tiny to hundreds of miles across. Yet, meteor impacts all follow a given set of circumstances, with results based on the size of the impacting meteor and the speed with which it traveled. This means that craters are formed on impact by meteorites. The impact produces shock waves that are created both on the surface of the moon and inside the meteorite itself. These shock waves release energy, forming areas of vaporized, melted, and crushed debris fanning outward from the point of impact. The hole created looks like an inverted bowl, and they are normally 4 times wide as they are deep. The material ejected on impact forms a raised rim rising around the surrounding surface. With small craters, formation ends when excavation stops. This forms a simple crater in only a few seconds. However, larger impacts from craters many miles wide take several minutes to complete, These impacts formed complex craters. Another feature associated with impact craters are crater rays. These bright and often striking features can be easily seen from Earth, emanating from the crater Tycho, seen here, and Copernicus, seen here. Rays are formed due to the interaction of a shock wave, that we mentioned previously, that's generated when a meteor strikes a surface. If the surface is initially smooth, this creates a similarly smooth shock wave that disperses the ejected grains evenly. This type of impact creates no rays. But with an uneven surface, this shock wave becomes irregular or unbalanced, causing the ejecta, that is the material thrown out of the impact site, to clump in small areas and form rays that fan out from the impact zone. These rays are extremely reflective of sunlight because tiny glass spheres are created during impact by fusing the lunar dust into glass. The tiny glass spheres are spread across the lunar surface in the ejecta after the impact of the meteorite. The next time you look at the moon and you see all the craters, think of how they're formed. These are important features, made even more interesting when you know how they were created. Last week we pointed out some of the more prominent features on the moon, but we haven't answered the question, why is the moon so different from the Earth? This is a complex subject and it involves the geology of planets as well as moons. To begin with, the moon has no atmosphere like Earth's, which is in a constant state of motion about the planet, with winds that erode and wear down its surface over time. Think of sand dunes on Earth and how the wind moves them constantly, reshaping the landscape. Clearly, some earthly dunes are huge, but nothing like this is present on the moon. Water is another key factor in shaping the Earth's surface and constantly removing evidence of meteor impact from the past. The Earth has vast oceans whose pounding surf relentlessly wears away at the rocky shore, eventually reducing them to sand. We have lakes, and we have mighty rivers whose rushing water grinds rocks into sand grains, much like the shorelines of our oceans. Although some evidence remains of meteoric impacts from the past, they are much more difficult to find on Earth, unlike the moon. The great period of meteoric bombardment of the Earth and the moon ended some 3.5 billion years ago. Yet evidence of meteor craters still can be found here. A good example is the one in Arizona, created by the impact of a large meteor about the size of a car some 10,000 years ago. And this one in Peru, which is less than 100 years old, formed by a meteor about the size of a small desk. In geologic time, these prominent craters will vanish from the landscape. On the moon, they remain forever. Another characteristic that the Earth possesses over the moon that reshapes our landscape are volcanoes. Known for causing great destruction when close to people, they're actually the Earth's source to replenish the land, reshaping its surface and providing fertile soil for both people and animals alike. Without an atmosphere, wind, water, and even volcanoes, the only thing left to erode the moon's surface are mainly solar wind and impact from meteors. It's for this reason that many of the moon's features look new when they are actually millions, if not billions, of years old. The telltale evidence of the Apollo landings can still be seen today, just as they were when they were made. Like the first footprint on the moon from Apollo 11 and the Apollo 12 landing site, both perfectly preserved. Without an atmosphere, science focuses on the only activity remaining on the moon: volcanism. Even though the moon ended its major volcanic period 3.5 billion years ago, younger features have been recently found which date to around 100 million years. Although true volcanoes no longer exist on the moon, the evidence for both past and more recent volcanic activity remains today and can be seen if you know where to look. Here is a view that shows some of those volcanic sites. Looking at specific types of features, we begin with sinuous rills, often found at the edge of lunar mare, and are most likely ancient lava tubes created by volcanic activity resulting from the impact that formed the mare billions of years ago. Other examples are dark mantling deposits found in Mare Vaporum, by the crater Copernicus, and around the Aristarchus bulge. This is material which was brought to the surface long ago, was originally formed deep within the moon, and brought to the surface most likely from the impact of a mare-forming meteor. The Aristarchus area is of particular interest due to the possibility of volcanic outgassing seen in modern times by telescope. These events come in the form of a colored haze appearing over the area. Called lunar transient phenomenon, they come in a variety of colors: reddish, green, blue, or violet, and they provide darkening or lightening of a particular area. They can also appear as a foggy patch and can even make permanent changes to the lunar landscape. Just another surprise to add to a growing list of lunar mysteries. The moon and all other moons and planets in the solar system exhibit different characteristics, geology, and certainly history. It's up to us to understand those differences as we explore ever deeper away from our home planet Earth, out into the vastness of space.